Machine learning, it's a term that gets thrown around all the time, right? But have you ever stopped to wonder, how does a machine actually learn? It's not some kind of magic trick. And believe it or not, there's more than one way to do it. So today, we're going to unpack the three main ways machines get so incredibly smart.
So yeah, how does a piece of software go from being, a total blank slate to suddenly predicting things, finding hidden patterns, or even crushing the world's best players at super complex games? It's a really cool process, and it all boils down to one thing: how it's taught.
You know, it's actually a lot like people. We all have different ways of learning, right? Well, machines are kind of the same. We can basically group their learning styles into three main categories, or paradigms. Each one is built for a totally different job and uses a different type of data. And yep, we're going to dive into all three. All right, first up, we've got the most common method you'll hear about. I like to call it learning with a teacher. The official name is supervised learning, and honestly, the name pretty much tells you everything you need to know about how it works. The easiest way to think about this is like studying with a giant stack of flashcards. Seriously, on one side, you've got the question, the data, and on the other side, boom, you've got the right answer. The machine just grinds through these examples over and over and over until it starts to see the patterns.
So the absolute key here is that the data is already labeled with the correct answers. The teacher in this scenario, that's the human or teams of humans who had to painstakingly prepare all that data. And let me tell you, that is a huge job. Labeling all that stuff can take forever and cost a ton of money, but what you get at the end is this perfect, pristine answer key for the machine to learn from. So it really comes down to two things. First, the input data has to be labeled. For example, imagine you have 1,000,000 photos, and every single one is tagged either cat or not a cat. Then, the goal is for the machine to take everything it learned from those examples and get really good at identifying cats in brand new photos it's never ever seen before.
Okay, now for our second method, which, well, it takes a completely different road. If the first one, supervised learning, was like having a teacher spoon feed you the answers, this next one is all about being a detective. Let's talk about unsupervised learning. Just picture this. Someone hands you a massive box filled with thousands of random, unsorted items. And there's zero instructions. None. That's what unsupervised learning feels like for a machine. Its job is to stare at all this messy, chaotic, unlabeled data and just start finding connections, to start putting things into groups all by itself. It's literally like a detective sifting through evidence looking for clues. So the core idea is pretty straightforward. The machine gets a huge pile of data with no labels, no right answers, nothing. The goal here isn't to predict a specific thing, like, is this a cat? Instead, its job is just to explore all that data and find any hidden patterns or structures that might be lurking in there, completely on its own. Right, so the input is just raw, unlabeled stuff. Think of a giant, messy spreadsheet of customer purchases. The goal? To find patterns. For example, the algorithm might start to notice, hey, this group of people all seems to buy coffee and bagels, and this other group buys dog food and toys. It automatically clusters them into groups based on their behavior without anyone ever telling it what kinds of groups to look for. And that brings us to our third and final style of learning, and you guessed it, this one is different all over again. This one isn't about studying a pile of data at all. Nope. This is all about learning by doing. Let's get into reinforcement learning, which is basically like learning to play a game. Seriously, just think about how you learn a new video game. You try a move. If it works out, you get points. That's a reward. If you mess up, maybe you lose a life. That's a penalty. After a while, you just naturally start doing more of the stuff that gets you points, right? Well, reinforcement learning works in exactly the same way. Now, there are a couple of key terms you'll hear: agent and environment. The agent is just our learning machine, our little player. It's doing stuff, taking actions inside an environment, which could be anything from a chessboard to a complex simulated city. For every single action it takes, it gets feedback, either a reward for doing something good or a penalty for doing something bad. And its whole goal, its entire reason for being, is to figure out how to get the most rewards possible over the long run. So you can see how different this is. Unlike the other two methods, the input here isn't some fixed, static spreadsheet of data. It's live, dynamic feedback, rewards, and penalties coming from the world it's in. And the goal isn't just to make one right guess. It's much bigger. It's about developing a whole strategy to win, or finding the absolute best series of moves to hit a long-term goal. Okay, so there you have it.
We've got the teacher, the detective, and the player. Now let's put them all side by side to really hammer home what makes each one unique. This table really lays it all out, doesn't it? Look, supervised learning, it absolutely needs that answer key, that labeled data, so it can learn to predict things. Then you've got unsupervised learning, which has no answer key, and its whole purpose is to find those hidden structures. And finally, reinforcement learning just throws the whole idea of a data set out the window. It learns from rewards and penalties to figure out the best strategy. You know, if there's just one thing you remember from all this, let it be this key difference. Supervised and unsupervised learning, they're all about analyzing a static, pre-existing set of data. That's their world. But reinforcement learning is a completely different beast. It's about an agent being active, out in the world, a dynamic environment, and learning as it goes.
So why should you even care about any of this? Well, because these 3 learning methods are already powering the tech you use literally every single day. That spam filter that keeps your inbox clean? Classic supervised learning. It was trained on millions of emails that humans had already labeled spam or not spam. How about your Netflix recommendations? That's unsupervised learning at its finest, finding patterns in what millions of people watch. And those really advanced systems like smart thermostats that learn your routine, or even self-driving cars, they rely heavily on reinforcement learning to constantly adapt their actions to what's happening in the real world.
And that just about wraps it up. We've met the student, the detective, and the game player. Each one is incredibly powerful in its own way. So the question I want to leave you with is this. Now that you know the rules of the game, now that you know how machines learn, which of these styles, or maybe, just maybe, some combination of all 3, do you think is going to be the one that truly defines our future? Something to think about.